Hello everyone. Today we will learn about the ensemble technique. Now, ensemble technique can be divided into two parts. One part we called bagging and another one we called boosting. Now, under bagging, we normally consider random forest, whereas under boosting, we have add a boost, we have gradient boosting, and we have XGBoost. Lot of other algorithms are also available, but high level, these are the algorithms we normally classified under ensemble, in bagging and boosting. Now, bagging sometimes has been classified as a different name also, that is called bootstrap aggregator. Okay, this is sometimes called as a bootstrapped aggregator. So, what is the general concept of bagging and boosting? Today, we'll mainly learn that, and then in the next session, slowly we will learn about the random forest algorithm, then ADA boost, then gradient boosting, and then XGBoost. Remember, all these algorithms are depending on decision tree. So I will suggest, if you are not clear about the decision tree algorithms, please go through and review these sessions, especially how it is handling the classification problem, how it is handling the classification problem, how it is handling the regression problem. Understand that, and then think you are good to understand for the random forest or any other algorithms. Okay, so let's jump in and try to understand high level what is the bagging and boosting algorithms are. So let's first understand the bagging concept. So first understand the bagging concept, and in general, I think kind of you're familiar that we have some training data which we pass and create a model, and then we pass some test data and which provide us the output. That's a high level way any model works. Okay, let's consider we have some data sets. We have our data sets, and from this we are creating multiple models. So we will create model 1, we'll create model 2, something like this, and we'll create model 3. Now, every time when we create this model from these data sets, we will send some sample data. So we will send some sample data, not all the data. So this is my entire population, and from this population every time we'll send some sample data. So like for example, probably D1, D2, D3, D4, and Here probably I have d numbers of data. So always remember this d1 or d2 or this kind of numbers are always less than d. So for example, if d is 500, probably I'm here sending 100, here sending 100, something like this. Now in general, when we are talking about the bagging concept, these algorithms can be any algorithm. It can be Navy biased algorithm, or it can be logistic regression algorithm, anything. Okay, especially when we talk about the random forest, then we have to remember that these algorithms are decision tree. These models are decision tree. So let's consider first um, how we will get the final result. So we build models like this and all are running in parallel and independent way. And suppose for logistic regression problem, this models gave me the output 0, 0 and 1. So what will happen in this case, that it will go for the max voting. So in this case it will go for the max voting, and it will say my output is 0. So this is for the classification problem. In case of regression problem, what will happen, that whatever values are coming here, then we will create the average, and that will give me the final regression output. So I hope kind of you understand what is the bagging concept, that first we are creating some small models with the sample data, and then we are basically doing some voting mechanism for classification problem or regression problem, and finally identifying our uh, numerical variables for the regression problem. Okay, so this is very important. So I think just let me highlight this probably in a different color. So max voting or voting concept for classification problem, and when you are doing the regression problem, it's a average concept. So that's the thing for bagging, if you understand this. And why we are doing this thing, that is again because each of this decision tree, when we build this decision trees has some limitations, right? What are the limitations it has? That it can overfit. So overfitting is a problem. We can eliminate that overfitting chance, because now we have multiple models, and from that whatever result is coming, we're selecting that. Then another thing is low bias and high variance problem, which is same actually, high variance problem. And this can be also we can reduce by this bagging approach. Okay, that's why we are going for the bagging approach. So all these problems can be reduced by bagging approach. Okay, now we'll see the high level, what is the boosting approach. Okay, so now we'll talk about the boosting approach. Okay, so what here we are doing, in the bagging approach we saw that we are building some models and then all the parallel models giving us the result. In boosting approach is little different. Here we are building multiple models, but first of all, they are not in parallel, they are in sequence. They are in sequence, and we are passing the training data. And what is happening, like the first model will do this work and there will be some wrongly predicted data. So there will be some wrongly predicted data. Okay, we'll pass that into this model, and then we'll pass into this model. So basically, individually, these models are called weak learner. Weak learner. So what is the boosting mean actually? So multiple weak learner, when we are combining the outputs, then we are getting a strong learner. Strong learner. So that's the main concept of the boosting approach. So boostings, basically you build a model, whatever wrong information, pass it to the another model, next model, like this, and you have to basically build a strong learner. This complete thing will be your strong learner, and then this will be your final model or final output. Now here definitely you have to, like where exactly you need to stop and all those things. So there will be some hyperparameters and we have to train those hyperparameters also. Hyperparameters, and then we have to build the final learner. Okay, so I think the bagging and boosting concept is clear. Next we will focus on the random forest. Okay, so in our next session or in continuation of this, what we will do, we'll learn about random forest. And random forest again is a bagging technique. It's a bagging technique. Okay, and remember I told you in the bagging technique, normal concept is you can have any kind of model. You can build like any kind of model, and based on that you can take a decision. But when we are talking about the random forest, our all the models will be decision tree. All the models will be decision tree. That's the main thing of the random forest bagging technique. Okay, and we'll learn it now. Okay, so let's understand the random forest bagging technique. Random forest bagging technique. Overall, it is almost similar kind of concept like whatever we explain in the bagging. Only thing is that here, along with the row sampling, we are doing the column sampling also. So basically again the same concept, we are creating multiple decision tree. So decision tree 1, decision tree 2, decision tree 3, and decision tree 4, something like this. But only thing is here we are doing row sampling, row sample, plus we are doing the feature sampling also, feature sample. And what is helping, like why we are doing this row sampling and feature sampling? What is the advantage of doing this thing? The advantage of doing this thing is basically we are reducing the overfitting chance. We are reducing the overfitting chance by doing this way. Okay, so what we are doing, we are doing row sampling plus feature sampling. And always remember, like in your data set, suppose we have features like f1, f2, and fn, and probably we have data this thing, and probably suppose row sampling we are using D dash, and feature sampling probably F dash or M dash, whatever is okay. So remember this thing, this D dash should be always less than D, and M dash should be always less than your N. Okay, if we have the N number of features. Okay, so that's the thing. And then finally, again, for classification problem, like if we have this kind of situation, then it will give us the majority voting. So what it will do, it will give the majority voting. And for regression problem, if it is a regression problem, then it will give the average. Okay, average by which we can calculate the final value. But the important concept here is basically these two terms or these two things. Remember these two things when we are, it's a, so first of all, when we are talking about random forest, it is a bagging technique. It is a bagging technique. It's a bagging technique. Second, we are doing row sampling, row sample, and the feature sample. Okay, and while we are doing things, this will help us to reduce the overfitting possibility, row sample and feature sample. And then we will do hyperparameter tuning and all those things. One thing remember, like all these things whatever we are building here, these are nothing but a base learner. Everything whatever building we are here, these are all base learner. And finally from this base learner we are getting the actual results by max voting. So either for classification problem it will be max voting, and for regression problem it will be average thing. Remember, when you will do the sklearn will do internally all these things for you, but you need to understand this concept, like how it is under the hood it's working. That's very important. Okay, so that's basically the random forest, and we will show you the practical example in the next class. Okay, high level I think it's clear how the random forest bagging technique is working. So hopefully this will help you to clear any kind of interview. If you like this explanation, please give a thumbs up or subscribe my channel. Thank you. Have a nice day. I'll put these things into my GitHub page so that at least you will have some reference like whatever we discussed, and it will be a good note for you. Uh, Thank you. Bye. Have a blessed day.